to the pneumatics.
Alright, so this is our pneumatic power pack. If you want to see how we made it, I've got another video explaining the entire process. Since then, we've added the battery pack. As you can see, it turns on. We're going to put a switch in line so you can just flip the switch. Unfortunately, this lead acid battery will not last very long. At peak, this air compressor can draw 40 amps, which means this battery will last maybe 5 minutes. So down the road, we're going to be upgrading to a nice beefy lithium-ion battery pack, but until then, this will have to do. So one thing to note is this air compressor can go up to 200 psi, and that will be the standard pressure for this tank. But the leg cylinders are actually only rated for 125 psi. We can probably push 150 psi without being too risky. But at 125 psi, they'll lift 800 pounds. That means at 150 psi, you're probably looking at 1,000. So together, that's 2,000 pounds. Anyways, we're going to have to regulate the pressure down from 200 to the 125 or 150 psi, and we can do that with this little pressure regulator here. And there's a bit of air in the tank still right now. So basically, we can adjust this to the pressure we will want for the legs. So in the interest of saving time, we're not going to use solenoid valves for this test. We're going to use manual valves. So this is actually a pneumatic blow-off gun, which is kind of nice because it's got a lever action here which allows you to control the flow of air. So what's going to happen is we got our supply line coming from the tank. That's going to plug into the gun like so. This is going to split off with a T, and these two hoses will go to the pneumatic cylinders. So then when you press this, you'll inflate the cylinders and stand up, and then the other gun will be the opposite. When you press this, it'll release the air from the cylinders, allowing you to drop down. And since it's lever, I should be able to get a fairly smooth control of up and down using these two things, and they'll probably be mounted off of my belt somehow. I haven't figured it out yet, or they could even be in my hand since this is really a leg test, not an arm test. Alright, so the reason I picked this work belt is because they sell a lot of different accessories for it, which is awesome for the whole idea of having this as a very modular exoskeleton. So for example, they have these nice little clips that fit onto the belt, and then they have an attachment point for adding like holsters, tool holders, and whatnot. But they also have a hammer holder. Now this just slips on like so. It's made of a really durable, thick plastic. And because there's not actually much weight being transferred through this, basically just my weight, that's it. What we're going to do is we're actually going to remove the hammer holster part, and we're actually going to attach it to the steel frame for the hips. So let's try doing that. Alright. So one thing we did notice quite quickly is that we need to put a locking pin into the ankle joint where it connects to this. It's quite easy to have it come out, but other than that, yeah, see, I'm already out. So we need to create a locking joint for that. Alright, so we got the ankle joints to lock properly now, I think, so I'm trying to walk around a bit. So if you notice, I don't have much hip flexibility at the moment. That is going to change. I'll be putting The same universal joints that I have on the ankle on the hips, but for the purpose of this test, we're going to keep it this way just so it's most structurally sound. Backwards.
Yeah.